Okay, the next thing we're going to look at is inverse functions. So if we've got a function f of x, its inverse function can be written as f to the minus 1 of x. Inverse functions have got a couple of properties. If we plot any pair of inverse functions, they will have a line of symmetry between them, which will be the straight line y equals x. We also find that if we do f of f to the minus 1 of x, so perform the f function on the inverse of the f function, we always get a result of x. Quite often that comes up as a question in a part C, which says what is the connection, and is normally of 1 mark. And if your result was x for the part B, say, the connection is that they are inverse functions. Okay, so inverse really meaning that it's an opposite function to the original function. So we're going to first of all start by identifying inverse functions. So if we've got the function x plus 11, let's find the inverse function. Okay, so a good way of doing this is starting with x. To get to the function f is x plus 11 gives me x plus 11. So the inverse function then is to do the opposite, and that will be x take away 11. So if f of x is x plus 11, then the inverse function is x minus 11. Now we can also see if this result is true. F to the f of minus 1 of x, that would be f of x minus 11. The f function tells me whatever's in the bracket to write it down and add on 11, whatever's in the bracket to write it down and add on 11, which gives me, as expected, the result of x, which means these are inverse functions. Okay, so let's try another. Let's find the inverse function to the function 10x. Okay, so the function 10x, so whatever's in the bracket, you write it down and you times it by 10. So the inverse function would be to divide by 10, x divided by 10, or 1/10 x. Let's just see if that property is true again, which is that the inverse functions should be equal to x if I do f of f minus 1 of x. So that's f of x over 10. So the inverse function, or rather the f function, is whatever's in the bracket, you write it down, you multiply by 10. Whatever's in the bracket, you write it down, multiply by 10. Those two cancel out, which gives me that result of x again. Okay, so let's try some more detailed examples. We've got f of x equals 2x plus 5, and let's find the inverse function of x. Okay, so this is a composite function, so whatever's in the bracket, we've doubled it and then add on 5. So times it by 2 to get 2x, and then add on 5 to get 2x plus 5. Okay, so the inverse function then would be, first of all, to do the opposite and work backwards. So let's undo the function, x minus 5, and then the opposite of multiplying by 2 is to divide by 2, x minus 5 over 2. So the inverse function to 2x plus 5 is x minus 5 over 2. Let's one final time see if we get a result of x when we do f, bracket f minus 1 with x. Okay, so that'll be f of the inverse function, which is x minus 5 over 2. The f function is whatever's in the bracket, double it and add on 5. Whatever's in the bracket, double it and add on 5. These two cancel out, gives me x minus 5 plus 5. Those two cancel out, which gives me that result of x. Okay, let's try a few more. So, find the inverse function of f of x, where f of x is 7x plus 2. And we're looking for the inverse function. Okay, so the function for f is to write down x multiplied by 7 to get 7x, and then add on 2 to get 7x plus 2. So let's undo that function to get the inverse. So we're going to work backwards and take away 2, which will be x minus 2, and then divide by 7 to give me x minus 2 over 7. The inverse function is given by x minus 2 over 7. Okay, let's try another. We've got a function g, which is 2x squared. Find the inverse function. Well, the first thing that I do to x there is square it to get x squared, and then double it to get 2x squared. So undoing the function then, the opposite of doubling it will be to divide by 2. And then the opposite of taking or squaring will be to take the square root, so it will be the square root of x over 2, which is the inverse function. Okay, let's try another. We've got a function h of x, which is x cubed plus 7. Find the inverse function. Okay, we start with x, and then cube it to get x squared, and then add 7 to get x cubed plus 7. So start with x, let's undo the function, take away 7 will be x minus 7, and then the opposite of the cube will be the cube root, which is the cube root of x minus 7, which is then the inverse function. Let's try another, which will be to find the inverse function of f of x, where f of x is 5 minus 3x. So we start with x and multiply by minus 3 to get minus 3x, and then add on 5 to get 5 minus 3x. So let's undo that. The opposite of adding 5 would be to take away 5x minus 5, and then divide by minus 3 to get x minus 5 over minus 3. Okay, I can divide top and bottom here by minus 1, just to tidy it up a bit, and that will give me 5 minus x over 3. Okay, let's try this one. F of x equals x plus 1 over 2. Find the inverse function. Okay, so the first thing that we do then is add on 1 to get x plus 1, and then divide that by 2 to get x plus 1 over 2. So let's unbuild the function. The opposite of dividing by 2 would be to multiply by 2 to x, and then the opposite of adding on 1 will be to take away 1, 2x minus 1. Okay, so let's try another. G of x equals 3 root x plus 5. Find the inverse function. Okay, so we start with x, and then take the square root to get root x, then we multiply by 3 to get 3 root x, and finally add 5 to get 3 root x plus 5. So working backwards, start with x, I would take away 5 to get x minus 5. I would then divide by 3 to get x minus 5 over 3, and then the opposite of the square root would be to square it, and that would be x minus 5 over 3 all squared, which would be the inverse function. Okay, let's try one final one. The function f is given by a half of x plus 9 in a bracket. Find the inverse function. Okay, start with the x, and then add on 9 to get x plus 9. We then divide that by 2 to get a half of x plus 9. Okay, so the inverse function, start with x, we then multiply by 2 to get 2x, and then take away 9 to get 2x minus 9. Inverse function, 2x minus 9. Okay, let's look at a question like this in a wee bit of context. of other things that we've learned. F of x equals 2x minus 1. G of x equals 3 minus 2x. And h of x equals 1/4 of 5 minus x. Part A says find k of x, where k of x is equal to f of g of x. Okay, so k of x is f of g of x, that's f of 3 minus 2x. The f function tells me whatever's in the bracket to write it down, double it, and take away 1. Whatever is in the bracket to write it down, double it, and take away 1. That'll give me 6 minus 4x minus 1, which is 5 minus 4x. Okay, so that's part A. Part B, find a formula for h of k of x. Okay, so the h function is up here. I've just worked out that k of x is equal to 5 minus 4x. So I'm looking for h of k of x. Okay, so that's h of 5 minus 4x. Okay, the h function then tells me whatever's in the bracket goes into a bracket with 5 minus before it. So let's just take that down. And is quartered at the start. So we can see there that that is just a straight swap. Where I seen x, I replaced it with 5 minus 4x. Okay, so I'm just going to tidy this up. That'll be 1/4 of, well, 5 minus 5 cancels out. I've then got a minus 4x, so it's 1/4 of 4x. 1/4 of 4x is x. Part C then says, what is the connection between h and k? Well, if we've got a result of x, we've seen previously that that means that those functions must be inverses, and it's a result of x between h and k which generates that conclusion.